This conference will now be recorded.
So let me open data set. Yes. So as usual, I'm going to start with respect to your markdown. I'm just giving an markdown document as hierarchical clustering. I'm going to execute this. Then I'm just giving your subheading like university data set. And whatever the necessary libraries, that is something called as your pandas, numpy, and for your scaling, for scale. So for scaling is nothing but your standardization. If you want to do standardization, the formula is z equal to x minus mu divided by sigma. So in RStudio, you might have used a function called as scale. So in your Python also you have a function called as scale, but you should use this library. So from this particular library, from sklearn.preprocessing, you need to import this function, and then you need to use this function in order to scale your data. Scale your data in the sense standardize your data. Standardize your data, or you can call it as normalize your data. Normalize your data. It is like this. So apart from that, as usual, matplotlib.pyplot or pylab as plt, these are your 4 libraries I'm going to import for your clustering operation with respect to your hierarchical clustering. And as usual, if I don't want this, I can ignore this, or if I want, I can use this. So what is this line of code does, Rakesh? Cell number 5. Rakesh, are you there? You're not audible, Rakesh. It is nothing but read underscore CSV is a function, and you are reading your local file, that is your data set, from this particular path by using your pandas library. That is nothing but your pandas library is having a function called as read underscore CSV, and you are storing this data set into a variable called as univ. And after loading this, I'm going to display my first 5 records by using a function called as add function. So it will display your data set first 5 records. So then I want to see the dimension of my data set. So in your RStudio, it is simple. It is dim. You can pass it as univ. But when it comes to your Python, it is shape is a
Shape.
keyword which will display your number of rows and number of columns.
Columns.
See, by this time you should have understood each and everything. How does it do? And this one I'm going to remove this. Sorry. So this one I'm going to execute. It says that you are having 25 records and 5 columns. So it is your 25 rows and 7 columns. 1, 2, 3, 4, 5, 6, 7. So these are your 7 columns. So I'm going to delete this block by using dd, and also here again I'm not going to run this. So here I'm going to normalize your data. Normalize the data from your second column till your last column. So that is why I'm writing it as scale function here, which I have imported from sklearn.preprocessing scale function. University is your dataset name, and you are specifying the index location. Index location is from scale all the rows, comma, from first column. Because you're 0, 1, 2, 3, 4, 5, 6, you should not specify it as 0th column, you should specify it as from first column. So I'm going to specify it as first column like this. So it is going to scale your data set and store the scale data set in a variable called as df underscore norm. df underscore norm. So I'm going to change this. Instead of df, I'm going to put it as norm data. I'm just going to put it as norm data. So I'm going to execute this. See, this is your normalized data. This is your normalized data, and this particular line 8 function, see, let me just cut it down. As of now, I'm going to execute this. It is executed. It has executed. But if I use this norm.add function, it will not display because it will throw an error because it is not an data frame. It is an array format. This is your array format. See here. So if you want to check what type of data it is, you can just, what is the function to check what type of data it is? What is the function? Rakesh, Manju? Yes, it is your
Type.
Yes, yes.
type.
Type.
Not
STR
equal. No, it is type.
type.
Type of norm data set. So normalized data, if it will show it as it is ND array. It is your n dimensional array. So n dimensional array will not work, or it will not take with respect to your head function or your tail function. So you need to convert this into data frame. For example, see here, what is there in your norm? If you want to see your norm, you can just type it as norm. It will display in the form of array. See, this is your array format. It is not showing in terms of tabular format or your data from format. It is showing in terms of array format. So your array doesn't work. So I want to convert your array data into what shall I do? Array data into data frame.
Into a
I want to
data frame.
convert that into data frame by using a function called as data frame.
PD
pd dot data frame open parenthesis. What should I pass here? Tell me. My normalized
it's
data.
norm.
Yes, it's your norm. I'm
Norm.
going to execute this. After this, if I run this nor, so again, once again, I'll just type it as type of norm. Type of norm. It will show as, earlier it was array type. Now it is data frame.
Convert.
Now, if you use your, now suppose if you run norm.add function, it will display your first 5 records. That is your normalized data. That is your normalized data. See, SAT score, top 10, acceptance ratio, student faculty ratio, expenses, and your graduation rate. Earlier everything was your original data. Now it is your standardized data. Now it is standardized data. So this is how you can use your scale function and you can standardize your data. So now I am going to implement your hierarchical clustering, and also I'm going to use your linkage. See, for that again I need to import 2 of the libraries. Same library, but I'm going to import a function from this. So from scipy.cluster.hierarchy library, I'm going to import linkage. So what do you mean by single linkage, Rakesh? Rakesh, what do you mean by single linkage? Manju. Lahari.
It is
To
it
location.
is hello. It is a
Hello.
library from
No.
is a
Forget
nearest
about your,
neighbor.
Yes,
is
it
the
is your
nearest
nearest
neighbor.
neighbor. It is your nearest neighbor.
Yes.
So nearest neighbor is called as single linkage. What do you mean by complete linkage?
The
Farthest
further
distance.
forest.
Farthest distance. Farthest distance is called as your complete linkage. That function you can use it by using this linkage. So that's the reason I'm going to import these two library part. I'm going to execute this. I've already done this part. I'm not going to do this again. I'm going to delete that. I'm going to delete that. Now I'm going to create some variables z, y, a, b. It can be anything. It can be anything. I'm going to create this linkage function, linkage, 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 df underscore norm. So this needs to be changed into norm because
No.
I've changed the dataset name to norm.
No.
I've changed the dataset name into norm. That is your normalized data. Normalized data. And here you can see that first model I'm building with respect to complete linkage. Complete linkage, I'm calculating the farthest distance, and second is with your single linkage, nearest neighbor. Third one is with your average linkage. Fourth one is with your centroid linkage. Generally in real time you should go with respect to complete linkage, but for example purpose here I'm showing with all these four linkages. And you should use your Euclidean distance format in order to calculate the farthest distance, largest distance, average of all the distance, centroid distance. So using your Euclidean distance, you should calculate your distance and store the distance into a variable called as z, y, a, and b. Z, y, a, and now you want to plot your dendrogram. So you want to plot your dendrogram. What is the function to plot your dendrogram in RStudio, Manju? Manju.
I forgot Yogesh.
Okay,
Fit
Rakesh.
function.
Huh?
Fit.
Wrong. Who is this? Fit?
Satish.
Wrong, Satish. Lahari, Muralidhar?
I think H cluster, H cluster, hierarchy cluster. Yeah.
No, wrong. Bharat? No. Ram? No. Sanjay? No chance. Debanshu? No. So the answer is simple. It is your plot. Plot of fit I used. Yes, correct, Murli. So plot of fit, this fit is nothing but your hierarchical cluster model name. This hierarchical cluster model name. So there you should use your plot. Here you cannot use your plot. You should use this function called as dendrogram. So there is a dendrogram which is your part of your scipy.cluster.hierarchy. Scipy.cluster.hierarchy. There is a function called as dendrogram. You can use that function. Before that, you can also set your figure size. This is default. See, I'm going to put it as comment. This also I'm going to put it as comment section. And these are your, sorry. SCH is your scipy.cluster.hierarchy. And this is your function dendrogram. Here you can pass either complete linkage, single linkage, average linkage, Z, Y, A, or B, anything you can pass it. So for example purpose, I've taken it as B. B is nothing but your centroid linkage. If you take it as centroid linkage, and you can also remove these two because this Hello. Hello.
Yeah, we
Am
can hear
I
you.
audible
Yeah, we
now?
can.
Oh,
Yeah,
okay, fine.
yes, yes.
One sec. One sec. One sec. Mummy. Near. Screen it, mom. ಹೇಳಿ ಅದ್ರ ಮೇಲೆ ಇಡು ಐರನ್ ಬಾಕ್ಸ್ ಇದ್ರೆ ಓಕೆ ಆ ಮಳೆ ಮರ ಬೀಳಂಗಿದೆ ನೋಡಿ. Okay, so now I'm going to remove this. So if by default it is going to plot your dendrogram like this. By default it is going to plot your dendrogram like this. You can see this, how does this particular plot looks. So if I remove that plot size, so I just removed your leaf axis, right? Rotational axis. So that is your x-axis is rotated. X-axis is rotational. It is not straight like this 17, 15. It is right written like this. Default it is taking it as some rotational value. So I'm going to add that, and also I'm going to change your leaf font size. I'm going to change this leaf font size. You can see here. You can see here. I'm going to change this to leaf rotation is equal to 0, and I'm going to give this leaf font size as 15, or let me put it as 9. So I'm going to execute it once again. So if I'm going to execute it once again, it is going to see here. Now leaf rotation is 0 because that is the reason it is displaying exactly at 17, 15, 13 like this. And leaf font size is also been reduced because I've reduced from 12 to 9. So these two are optionals. If you don't write these two also, it will work. These two also, it will work. It will work. But the problem here is, so this, you want to get your dendrogram like this. So if you want to get a bigger dendrogram, you should set your, you should you can set your figure size. You can set your figure size by using plt.figure. So under your matplotlib, there is a function called as figure. You can set your figure size how much ever length and breadth you want. Length and breadth in the sense your width and your height and width, how much ever you want, you can set it. So I'm going to give it as 16 versus 4, and I'm going to re-execute this particular line. So it is going to increase your plot size. It is going to improve your plot size. So see, plot size, and this is according to your requirement. You can change it, and also you can change your font size, and also if you want, you can change your font size. Let me put it as around 12 or 13. I'll put it as, so that 15 I'll put it, so that it will be visible clearly. So I'm going to change this. And suppose you want to display some title on this, see, this has been increased based on your font size, and I want to put some heading here. I can write as title function. I can use it from matplotlib. X-axis also you can give some labels. Y-axis also you can give some labels. So by using these three optional part, you can do that also. So title, X label, Y label, you can use it, and you can give the label for X-axis, Y-axis, as well as your title for your diagram. Title for, so this is the, what is not clear, Devanshu, what is not clear? The audio, because it started suddenly raining heavily, so that's the reason, Devanshu. We'll see. If not, I'll take once again, no worries on that part. So that, try to understand what I'm explaining. So this is your dendrogram. So I've just used this. I've just use this dendrogram, and here I've given the title. Here I've given the title, and here I've given my y-axis as distance, and here I've given it as my x-axis as my university number. You can see here university number is also been displayed. University number is also been displayed. You can see here. You can see here, and I'm going to delete this. It is just help function. So now I want to implement your hierarchical clustering. So hierarchical clustering function in your Python is called as agglomerative clustering. Agglomerative clustering is the name or the function. Syntax to plot dendrogram, it is simple. Rakesh, you should pass your, see here, Rakesh, once again. So you should use this dendrogram. You should use this dendrogram function, and this function is under your scipy.cluster.hierarchy dot dendrogram. Dendrogram is a function, and you can pass your linkage. We created some linkages right here. Distance we calculated based on complete single, that you should pass it here. You should pass it as Z or A or B or C, whatever it is, and you can just give it as, you can directly close it, but these two are your optional part. These two are your optional part. It is only dendrogram and the distance variable, whatever you have calculated based on single linkage, complete linkage, and your average linkage. So instead of, yes, forgot to say you that I am going to change this because I have plotted it on centroid. I don't want to use centroid generally for hierarchical clustering. I go with Z. So let me just try to plot your Z here, and I'm going to remove these options. I'm going to remove these 3 options or 4 options, and I'm just going to use this. You're getting Rakesh now? I'm going to remove everything, and I'm going to plot my basic dendrogram. I don't want to give my font size, plot size, anything. So simple, I'm going to use this. And these 4 also optional. These 4 also optional, just for giving the names. Just for giving the names. You can directly use this, only this part. Got it, Rakesh? It is sch.dendrogram is a function, and you can pass your variable, whatever the variable you want, whether it complete, average, single, or centroid. So just that's it. Got it? Got it, Rakesh?
So Yogesh, on the
Yeah.
y-axis we have distance. So that
Yes.
is distance means how is it measured in units?
How it is measured in the units, in the sense it is your Euclidean distance. See, for example, if you are using square root of x2 minus x1 whole square plus y2 minus y1 whole square, it is taking with respect to your centimeter part. That's it.
Okay, centimeters.
It doesn't matter because here it is your distance. That's it. That distance is calculated based on your Euclidean. This is not your unit part will never come here. Unit part will never come. So if I don't want to pass it as distance, I can put something else, right? Here I have given the name. Here I have given the name. That's it.
No, like for example, if you want like for anyone to explain like the distance between any two points, like how you can say it.
Yes, distance between any 2 points is 1 centimeter, 2 centimeter, like this. You need to explain it. That's it. There's no other option. So generally,
Okay.
when you're talking with respect to statistics, nobody will ask you with respect to Euclidean distance unit. They will not ask you. If you're taking something with respect to your columns, if you're having a column called as distance, it can be 1 kilometer, it can be 2 kilometers, it can be 2 centimeters, 2 millimeters. There they might ask you. But when you calculate using your Euclidean method, nobody will ask you what is the distance unit here. Don't worry about that.
Okay. Got it.
Okay, for implementation of your hierarchical clustering, you need to import a library called as agglomerative clustering. So from sklearn.cluster, import agglomerative clustering function and use this agglomerative clustering function to build your hierarchical clustering. See, clustering using complete linkage method, because I've used it as Z, I'm going to use it as complete linkage and Euclidean distance. So I'm going to write it. This is your comment section. That's it. This is your comment section. So whatever the variable I am going to give, it is nothing but your hierarchical underscore complete I've given. That's it, nothing else. Because I'm using hierarchical clustering and also complete linkage, I've given it as h underscore complete. If you want, you can change it to hierarchical clustering. And I told you the function name is agglomerative clustering. I'm going to use the same function, agglomerative clustering, and you should specify how many clusters you need. How many clusters you need, you can specify using a keyword called as n underscore clusters. This is the parameters you should specify, the number of clusters. Number of clusters you can specify. Linkage is equal to complete. Linkage is equal to complete. So this is your complete linkage part. Complete linkage, and here you are passing based on your Euclidean distance. I want to measure the distance between the data points, and using all this, I want to fit this hierarchical clustering or agglomerative clustering on this particular data set. On this particular data set, by using your fit function, I need to change my data set name to the fit of norm. So this is my normalized data, so I need to pass it over. This is your distance part, and this is your complete linkage. This is your number of clusters. This is your function for implementing your hierarchical clustering. So I'm going to execute this, and apart from that, let me just copy all these things and execute it later part. So I'm going to run this. I'm going to run this agglomerative clustering. Because I did not run this, it is not executed. So I'm going to run it now. So now I'm going to add one cell here. I'm going to paste everything. Whatever I've copied, I'm going to paste it here. So here, what is this, right? This is your h underscore complete. If you just run this h underscore complete, the variable you stored the model, right? If you use that, you will not get any information. It will only display what type of clustering it is. That's it. See, whatever we have written, agglomerative clustering, affinity, computer full tree, auto, each and everything you are going to display. But you want to get what are the cluster numbers, what are the different cluster numbers, you should get it. So consider that this as your testing. See, h underscore complete is here, this one. Under this, you need to select your labels underscore. So this labels underscore, see, for example, I'm going to choose this much. I'm going to choose only this much, and I'm going to add it over here as labels underscore. So I'm going to execute. Now if I execute this, it will display which university belongs to which cluster. Which university belongs to which cluster. See, it is like this. First university belongs to second cluster, second university first cluster, third university, like this. So it is going to display your cluster number. That cluster number, I'm going to take it into a variable called as cluster underscore labels. Cluster underscore labels. I'm taking this cluster numbers and storing it in a variable called as cluster underscore labels. And apart from that, I'm going to come to this and I'm going to cut it and keep it separately. I'm going to execute this. So if I am executing this cluster underscore labels, this cluster underscore labels will be created, and it will display as series. Earlier it was displaying it as your array type. Now it is displaying it as series type. It is in your matrix format, rows and columns format. So either if you want, you can change it here only as your data frame. So I'm going to put it as data frame. I'm going to execute this once again. You'll be able to see it in your tabular format. First cluster, second cluster, first university, second cluster, second university, first cluster, third university, zeroth cluster. Zeroth cluster means first cluster, second cluster, third cluster, because in your Python, the index starts from 0, 1, 2, 3. That's the reason your index is starting here also. First university is shown as zeroth cluster. So that's it. So this is your cluster underscore labels. So next, I'm not going to run this because it takes space. So here I'm going to delete this, and I'm going to add one cell below this, and I'm going to paste it. I'm going to paste it. See, I'm creating one extra variable in your university dataset. I'm creating a new column called as clust in my university dataset, and which will have your cluster labels, which will have your cluster labels. Next to graduation rate, you are going to get one column called as clust, one column called as clust. Here you will be having clust, and that will have these numbers 2, 1, 0, 2, 2. So this is what I'm going to create using this line. And again, I'm going to use this univ.get function to display that. So I'm going to remove these two lines again and again. After that, after next cell, I'm going to explain these two lines of code. See here. Now it is displaying your cluster column here. Cluster column here. See. So Brown University belongs to second cluster, Caltech belongs to first cluster, CMU belongs to like this. So now I'm going to run one cell. So now I'm going to add two lines of code. I want Rakesh to explain me this. I want Rakesh to explain me this. Try Rakesh, even though if it is wrong, not a problem, because nobody is master over here. I want you to try. I'm going to paste this. Tell me Rakesh, what does this line of code does? Only this part. I want Rakesh to talk. Rakesh, are you there? Rakesh, no idea? Okay. Okay. So, Laurie, can you explain me this?
Index location is starting from 0 to 7 position.
What is this? 7 0 to 7. But why I'm writing it as 7 to 0, 1, 2, 3, 4, 5, 6? Manju, can you try?
Right. Yogesh, sir.
I
Yeah.
mean, seventh is the new column which we added now.
Yes. Fine.
The seventh column you are
So
bringing
what?
to first column.
Yes, that is
That will be the
important. So
first.
seventh column, you're see. Yes. 0, 1, 2, 3, 4, 5, 6, 7. So you are moving this cluster column to first position, and then remaining you are
Yeah,
moving to next. That's it.
we are
Remaining you are
rearranging the
moving to
columns.
yes, we are arranging the columns. So let me run this line of code and execute it. See, nothing. It is here. It has been moved to here. That's it. So now you can easily read this. Brown belongs to second cluster, CMU belongs to zeroth cluster, corner belongs to second cluster. Like the second cluster means it is third, because 0 means first cluster, 1 means second cluster. So this is how you can read. That's it. So this is your head part. This is your part, and again I've run the same thing. It is same part, and here this part. So you're having totally 4 clusters, 1, 2, 3, 4 clusters. You want to do the, see, this cluster might contain 3 universities, this cluster might contain 4 universities, this must contain 5, this might contain 7. So out of all these 3 universities, what is the aggregate SAT score? What is the aggregate top 10? What is the average expenses? Like this you should calculate for all these universities based on cluster. So I'm going to write it as your group by function. So I'm taking your university data set from index location. I need to take it from second column because first column is your cluster number, that is 0, and second column is your university, that is 1. So I need to calculate based on this point. So I'm going to write it from this, see here, from all the rows, second column I should start 0, 1, 2. So from this point I need to start it, and I need to go for ending column. So I'm writing here, and I'm using a function called as group by. Group by based on your cluster number and based on your average. Mean means it is average. So I'm going to take your average based on this. So it is like this.
Yogesh, could you just repeat it? The same 30th, 35.
This one.
Yeah.
See, consider that, for example, I'm taking, instead of taking it as a universities, I'm taking like this. So first cluster, Sanjay, Bharat, Imran. Second cluster is Lahari, Mega, and Rakesh and Manjunath. Third cluster is Ratnesh, Rahul, Satish, and Muralidhar, for example. So this Satish, sorry, these three persons average salary. I'm calculating this belongs to one cluster's average salary belongs to one. First cluster's average salary, comma, average experience, comma, average average percentage of hike. Like this, all the columns average you are going to calculate. Getting my point now? Based on your cluster
Yeah.
number, you are calculating the average of each and every column, because each and every cluster belongs to more than one universities. More than one universities. You are taking average of all those. You're taking
Okay.
average
Okay.
of
Fine.
all those.
Okay.
That is what I've run here, and it should be based on your mean. You can also pass it as median. You can also pass it as median.
Hi, Yogesh, Satish here. Just you need to check with you
Yeah.
regarding a cluster grouping. The cluster grouping also it will
Mhm.
do with the indexing with start with 0.
Obviously, right?
Yeah, okay.
Anything in Python will start from 0. So this is part of your hierarchical clustering. If you want to write this output, you can write by using a function called as to underscore CSV. You can write this entire data set with respect to your university, not this, your university data set. You can write it into a variable called as university1.csv into your local system. Into your local system, it will be saved. It will be saved. I'm going to write like this and I'm going to execute this. Sorry. university1.csv. So university1.csv will be passed. Will be passed. So if I'm going to execute this, it will be saved in my local system under a particular folder. Under a particular folder, you can see that in my local system. So if you want to write your results to your local system, you can use this function called as to underscore CSV. Now if I go to my particular library, I'm going to see that path. So let me just go to that particular Here you can see that University 1 is being created just now at 8:15 it is being created. 8:15 it is being created. You can just see here, and if you just open this data set, you'll be having your cluster numbers also along with your data. Along with your data. So let me open this and display your output. It is taking time. I don't know why it is. And this is how you can implement your hierarchical clustering. So meanwhile, I'm going to jump into your k-means clustering. K-means clustering. So I'm going to open my non-hierarchical clustering, that is your k-means clustering. We'll try to complete that as well.
Yogesh,
Yes.
Yogesh,
Yeah.
in the last problem, you have, I mean, assigned the Euclidean distance for four variables like complete and single, average, and centroid. Where
Yeah.
actually it was being used after we assigned it to that
Yes.
variable.
While drawing your dendrogram, I used it, right?
Mm-hmm,
I did not use all. I did not use all. I changed it from B to 0, right? See here.
mm-hmm.
See here. Either you can pass it as Z. Earlier I changed it to V. Now if you want, you can change
Oh
it to
yeah,
A also.
yeah.
See,
Oh yeah.
I'm going to change it to Y and I'm going to run it once again. So if I use your single linkage, your cluster looks like this.
Mm-hmm.
Your
Okay.
cluster looks like this. See here. How does your cluster look? See, this is your single linkage.
Mm-hmm.
Got the difference? So I did not run
Yeah,
each and
yeah,
everything. I just need to change here Z, Y, A, and B. I showed you for Z and B. Now I've just displayed as A or Y like this. That's it.
yeah.
But most of the cases we need to use the complete.
Complete linkage in hierarchical
Yes.
clustering. And for
So
k-means
Yeah.
we
clustering, we generally go with k-means clustering. We generally go with centroid.
centroid.
Yeah,
For
centroid.
where we use which scenario we'll use the single and other uh,
What?
further. Which scenario we can use other methods.
No, we don't use those two methods.
So basically, industry standard we use only the complete and
Complete
centroid
and
only.
centroid. Yes. Industry standard, we use only complete and centroid. So
Thank
let
you,
me
Yogesh.
go for non-hierarchical clustering. No worries. So let me go for non-hierarchical clustering. going to open your k-means clustering. It is easier than your non-hierarchical clustering. It's very easy, nothing to do much manipulation here. So I'm going to import all the libraries. See, and remember one thing, if you don't remember these libraries, just remember 4 to 5 libraries: pandas, numpy, matplotlib, matplotlib. These three are your mandatory. Apart from these three, remember uh, sklearn.preprocessing 1, sklearn.cluster1. These two remember. Remember these two. Or if you don't remember this also not a problem. At least remember sklearn. sklearn. Cborn. Cborn also you can use. So, but I'm telling you, if you don't remember anything, at least try to remember some 5 to 6 basic libraries. So here I'm going to use same pandas, matplotlib, sklearn.cluster. So your k-means is a function. K-means is a function which is available under sklearn.cluster. Scale is a function which is available under sklearn.preprocessing. And if you want to calculate the c distance, again you should use a function. And this one we don't remember. Generally, I don't remember. Most of the time I just Google it and I'll get it. Or just I'm going to use this SciPy and I'm going to get this. So it is like this. So it is like this, and import numpy as num. These 1, 2, 3 you remember generally, but these three you should try to remember when you are going for clustering applications. Clustering application. So I'm going to read all these libraries. I'm going to read all these libraries. So here I'm going to run same matplotlib inline. Ignore all these things are your mandatory. So here I'm going to read my dataset, that is read underscore csv, which is a part of your pandas library, and I'm going to import that into my local dataset called as univ. univ. I'm going to write it. And here I'm specifying university.ed. See, everything remains same: ed, shape, reading, importing libraries, everything remains same. Only the function name changes. Only the function names changes. That is mandatory, you should learn. Apart from that, you should understand the concept, when to go for non-hierarchical clustering, when to go for hierarchical clustering. So if you want to go for k-means clustering, your data should be huge data set. If you're having huge number of data or huge number of records, then you should go for k-means clustering. If you're having some 25 records, 50 records, less than 100 records, go for hierarchical clustering. See here, I'm going to do scaling. Same, everything is same scaling from your first column, because it is 0, 1, 2, 3, 4, 5, 6. So I'm taking from this column. I'm going to do your scaling and store it in a variable called as df underscore norm. df underscore norm. I'm going to, and here also I'm not changing it. Here I'm going to put it as it is. See, I'll just run it once again because I don't want to explain it to same again and again. So first I've ran this, and then I've converted this df underscore norm into your data frame by using data frame function, and I've created a new variable called as df underscore norm1. So now if I run this, you got it as one thing as norm1 is data frame. You got it. But if I execute after editing this to df underscore norm, it will not be your data frame, it will be your array type. So this will be your array type and this will be your data frame type. Just for understanding purpose, I have written like this. That's it. So now if I want to see what is the top 5 records, that is your standardized data. That is your standardized data, or you can call it as normalized data. 0, 1, 2, 3, 4, 5. So it is your SAT score, top 10, acceptance ratio, student faculty ratio, expenses, and graduation rate. So implementing k-means clustering. Implementing k-means clustering. So model is equal to k-means. Here I'm specifying directly k-means cluster, and you should specify just your cluster numbers, how many clusters you need. how many clusters you need, and you should fit it into a model. You should just store it in a variable called as model, whatever the variable name you can give. And after this model, you should fit this model onto a variable or the data set called as df underscore normal, which is your normalized data, which is your normalized data. You can fit it on that. You can fit it on that. I've run this and directly you can take it as model dot labels underscore. It will display your what it will display. Come on, cluster numbers. That's it. Which cluster first university belongs to 0, fourth, third, like this. 25th university belongs to second cluster, 24th belongs to first cluster, like this. So don't get confused. 0 means it is first cluster because your Python start from 0, index start from 0. Whatever the model name you are giving, right, you should use the same model here. That's it. And here same, I'm converting this model labels into your data frame and storing it in a variable called as md. And I'm going to create one variable called as cluster number in your existing data set next to graduation rate, and I'm going to assign this md, whatever I'm creating this cluster number, it will be assigned to this and you are going to get it. For example, what I'll do is I'm not going to run this. I'm going to make it as this. I'm going to run this. See, as of now, if I run this, I've not run this line because I've commented it. You're having original data set. You're having your original data set. And if I comment this also, it will only display the what type is your MD. MD will be in your data frame format because I've written it as data frame here. It is like this. So if you want to see what is there in your MD, you can use this md.add function. md.add function, it is going to display your which university belongs to which cluster, like this. Now I'm adding an existing variable, existing data set. I'm adding a new variable called as cluster number and store this md into this variable called as cluster number and display that university.add function over there. It is like this, 04300. So this has been added to your last column by creating variable called as cluster number. So if you want, you can change this number also. I'll put it as full form as cluster number. I'm going to execute it. See, just written the column name. And if you want to do your group by, you can use same university.I location 0 1 2 3 4 5 6 7 8. So I don't want to do like this. I'm going to put it as 2 3 4 5 6 7 8, and I'm going to put it as 0 and 1. So it is like this. Whatever you want, you can change it according to your requirement. And I'm going to display like this. I'm going to run it. See, now it has been, everything is been done opposite. So I don't want to do like this. I want to organize it in a correct way. I want this to be in the first. So how should I write? Come on, tell me now.
So you need
What all
Start
should I
from
write?
5,
Shall I write it from
5,
0 1 2 3 4 5? Okay, 5, then
5 to
5
3.
comma, no, 2
Yeah,
3
5.
0 1 2 2 will become your student faculty ratio. 5 should be starting. Fine. I want
Yeah,
university
fine.
next. 0 1 2 3 4 5 6 7
6.
I need. 6 comma 7 comma, then
Then student faculty ratio 2. Yeah,
it should be 0, right? 0 comma,
okay.
then it should be 1. Yes, then it
Okay,
should
top
be
10. Acceptance ratio
2
2.
and 3. 2 3 4. 2 3 4. Yes, I'm going to remove like this. Yes, you're having 0 1 2 3 4 5 6 7, and I'm going to run this line of code. See here, cluster number, university, SAT score, top 10 acceptance ratio, student faculty ratio. You are just passing the index number, nothing else. There is no rocket science. So just write down your column numbers and just arrange it based on your requirement, which one you want first, which one you want second, which one you want third. That is what is your understanding comes into picture. That's it. So this is about your this thing, and you can see your data by writing this one. You can write it into your local system university.csv, and this one you can use it as your pwd function. But from yesterday it's not working. Again it is working. So let me just check my update my libraries. So this is your pwd. Pwd is nothing but your present working directory. So this is in your k-means folder. So I will give just the name of a student so that it will be saved in the student's name. For example, I want to give it as bharat.csv. bharat.csv. It will save it in my local system. In the above mentioned path, it is going to be saved. So if I go to that particular path, bharat.csv should be saved. Bharat.csv should be saved. So let me just see whether it has been saved or not. And every day interviews are going on. One of my participant is being referred to Accenture and also is having interview with a company called as Confirm Ticket, I guess. CONFIRM Ticket, TKT. Confirm Ticket is a company. So he has cleared 2 rounds. He's having final round, and one more person, the same person, is having interview in Accenture on 3rd October, that is day after tomorrow. Is having telephonic round. So if you keep on updating, you can just try your luck based on your requirement and also based on your experience. So give it a try. So this is your bharat.csv. It has been created in my, I think he is having 3.2 years of experience, Rakesh. He has converted as 1.5 years into data science.
Best of luck to him, Yogesh.
Yeah.
My best wishes to him, Yogesh.
Oh, okay, fine, fine. Thank you. I'll just inform. So this is your data. This is your bharat.csv. This is your Bharat. See, if you don't get into successful in 1 or 2 interviews, so you can try. Probably 1 or 2 you might fail, and after that you might get a chance. So don't worry about failure. Failure will be a stepping stone for success. Stepping stone for success. This is your k-means clustering. K-means clustering. And one more important thing is, Rakesh, don't worry about 7 years, 6 years. Do nothing to worry, because one of my participant, he was having 11 years of experience. He has cleared in Dell EMC, and within 3 months he has joined, I think in the month of June, I guess June, July, August, September it is. 4 months back he has joined a company, Dell EMC, and already has visited 1 month on site for Hong Kong. Package will get very good, no worries. 11 years of experience. He has converted experience. He got around 24, I guess 22 or 24. I'm not getting this exact number. It is between 22 to 24 he got, and already out of 4 months he has already gone to 1 month Hong Kong, and yesterday he is back to Bangalore, and again he is going for a long term for US. Probably he'll be getting a 3 years chance. It depends. It depends. He has dedicated around 4 months. He has dedicated totally 4 months. Then approximately in this 4 months, he got around 4 offers. One is from Capgemini, one is from Cisco, one is from L&T, and one is from uh, Dell EMC. All these 4 he got, but he chose Dell EMC. But they gave him an offer like 22 to 24 lakhs. More than this, he got from Deloitte. But the designation what he got was in Dell. It is senior advisory data scientist. Senior advisory data scientist. That's the reason I'm telling you, don't worry about package. Don't worry about your. First thing is you should put your effort. Later you can try. There is no problem, Ram. There's no problem. I will help you out to prepare your CV, everything. Nothing to worry.
how much
You should
experience he
dedicate.
put?
First, you should. He has put 2 years
Is it?
experience. Out of 11, he converted 2 years of experience into data science. Okay, so tomorrow we are going to start. See, if you know Excel, if you know PPT, it is really very good, Ram. See, nothing is going to be wasted when you talk about data science or data analytics. Even though if you are good in Excel, really, you can demand 5% more. If you know SQL, you can demand 10% more, like that. Yes. You should dedicate. See, you should have passion. First thing is you should have passion, then everything comes automatically to you. You should not run behind that. Okay, so we'll stop at this point because I'm using some other net connection which is very low. So we'll try to connect tomorrow same time. Tomorrow it is a new topic called as dimension reduction algorithm. Dimension reduction algorithm. We'll try to complete this theory part tomorrow, and if possible we'll try to do it in R as well. Okay, thank you all.
Thanks, Yogesh.
Thank you. Thank you.
Thank you.
Okay, thank you, Yogesh.
Thank you all. Bye. Good night.